In this question, we are talking about if the series summation of n equals to 1 to infinity of an converges, and where an is the positive numbers, for all values of n. So which of the following statement must be true? So let's go one by one option. So we need to back solve that. If I talk about option A, so we are talking about limit n tends to infinity, a of n plus 1 over an. So this is basically a ratio test. And the ratio test tells us, so this limit of n tends to infinity of absolute value of a of n plus 1 divided by an, this must be less than 1 in order to be a convergence. So it is not necessary that it has to be 0. It can also be 1 by 2 or 0.5, or it can also be 0.1. So still we say it would be convergence. It is not like, so it must be equal to 0. So that's why it's not option A. Now, if I talk about option B, that is, B is that the value of an must be always less than 1. So this is not at all necessary because I can also have a geometric series where it can be greater than 1. So for an example, so if an is greater than 0 means I can also have a geometric series, something like, let's say 16, 8, then 4, 2, 1 half, and so on. And this is a geometric series, and where the common ratio is half. And in this value, so this series would still converge. And here the value of any term is still be, it can be greater than 1. So it is not like it must be less than 1. So this is also false. And the next one is the sum of this entire series must be equal to 0. No, that's not true. Basically, whenever it converges, of course, the nth term, the limit n tends to infinity of the nth term must be 0. So this has to be there for sure, but not the sum of the series. So that's why even option C is not the right answer. Then if I talk about option D, that n into an diverges. So let's see. Suppose if I take an as 1 over n cube or 1 over n or 1 over n power 4 or something. So basically, whenever they talk about which one must be true, it must be true for in every case. So even if you get an one example, one contradictory example, so which means which doesn't work. So this entire statement will be false. If an is 1 over n cube, my n times an would be 1 over n squared. And if you observe it, this 1 over n squared, so by the p series test, this one also converges. So it doesn't mean that if an converges, so if an converges, n times an would diverge. That will not work always. So that's why D is also wrong. So of course, E has to be true. If you take any example, let's say I take this example itself. So if an is 1 over n cube and an over n, so that's going to be 1 over n power 4. This one will also convert using a p-series test. So this option E works for all the sequence. So whenever all the series, whenever this an converges, an over n will also converge. So that's why option E is the right answer for this one.